Hello everyone! In my previous videos, I introduced Gradrigo as a real-time synthesizer for chiptune sound effects and described its programming language. Today I'm going to focus on how to use Gradrigo as a miniature audio middleware in Unity, and Gradrigo is going to synthesize sound effects in real time for us. To illustrate the process, I made a very simple clone of Arkanoid using Unity and its 2D physics. So let's start by looking at the game and let's talk about the sound design in Gradrigo and then about the actual implementation. The game opens with the countdown, and then we're bouncing the ball around the screen, and the ball is bouncing off the walls. It destroys those bars up there, and when we're not careful, it can be missed. Let's do the wall bounce sound first. For this project, I'm using Gradrigo standalone application. You can get it from the link below. It functions as a little IDE of sounds. That means that you can type the code and hear what it does right away. I am now entering the first box of my project. The boxes in Gradrigo can be understood as events in FMOS Studio, for example. Each box is essentially a sound that you can trigger. My box is called wall_bounce, and at the moment it's empty. I'm making it 0.15 seconds long, and it will produce a square wave with the period of 40 samples. That's probably not the best sound for this purpose. We have, Gradrigo has two noise generators. One is called Noise 5 and the other is called Noise 17E, and both are inspired by Atari 800 computers. And in general, the higher the number, the lower the pitch, and vice versa. And since we're simulating a sound of an impact, let's add a short fade out. Now let's save this file as gradrigo.txt and have it ready for a short moment later. Now we need to add Gradrigo to our Unity project. For that, we will need the contents of the Gradrigo Unity zip file that you can also get from my website. The file contains two assets, a C# file in scripts and a DLL file in plugins. I already had some scripts in my game, by the way. And now we need to add the Gradrigo script as a component to a game object. And the easiest is to add it to the object which also hosts our game controller script. And then we must not forget adding an audio source, because Gradrigo script implements onAudioFilterRead method of mono behavior, which feeds the audio from Gradrigo core to this audio source. And now let's bring the Gradrigo code that we saved earlier to a text file into this project. So let's create a resources directory in our assets directory and copy the text file here. And now let's write some code. So in my game controller, I want to have Gradrigo instance handy. So I'm making a public Gradrigo variable, and I'm setting it to whatever is the output of get component Gradrigo. And now I want to parse a string, and the string is this thing. So I can definitely just put it right here and it would work, but it probably would be easier if I just, if I just parse the text asset that I have put into my resources. It's going to make the editing much easier. And for that, I just want to say that I'm going to parse whatever is the content of the Gradrigo script. I just need to tell my game controller where the Gradrigo script is. Now let's implement the audio response to the collision of the ball and the boundary collider that I have put around the walls. So in my ball controller, which is the script which handles the behavior of the ball, I am going to expand my previous implementation of onCollision enter 2D. And when the ball collides with the object with the tag level, I simply invoke the method called startVoice from the game controller's Gradrigo. And as a parameter, I will put the name of the box I want to play. And what we're about to hear are the sounds generated by Gradrigo whenever needed. All right, so let's add the bar bounce, which is going to last 0.2 seconds. And it will also have a little fade out there, and it will be a loop of a square wave with the period of, let's say, 72, which is the C5 note. And let's make it a bit more elaborate and have this bar bounce box receive the parameter D, which is going to correspond to the pitch of the tone. And I will actually, and let's not use the direct period, let's use the MIDI numbers instead, so that the numbers would correspond to the MIDI numbers, like this. All right, and now let's make another thing. Let's have a baseline of 72, so that when we enter 0, we will start from the C5 note, and as we will add numbers, we would just go, 1, 2, 3, 4 semitones, or higher or lower, depending if it's a positive or negative number, from the C5. And now, so if we don't do anything, we would be able to hear the C5 note whenever a bar has been removed. So if I change the parameter, we will hear different note. And let's have our sound effect respond to how many bars we have already destroyed. And with each new bar destroyed, we will just play a note which is 1 semitone higher. So we will move the code into the game controller itself, because game controller knows how many bars we have already destroyed. And we can send the parameter to the box by concatenating it with the name of the box. So now when we play the game, we will hear different tone with each bar destroyed. Great. And now let's make the entire sound a little bit more interesting. So instead of just one impact, let's make a series of several impacts. So there will be this overall fade out, which is 0.2 seconds long. But I'm making some minor impacts there, and it's just going to be a loop of an impact and then a pause. So the impact is going to be 0.04 seconds long, and then the pause is also going to be 0.04 seconds long. Great. Yeah, now it sounds a little bit more intricate. Great. So now let's make the pedal bounce sound, which is also going to last 0.2 seconds, which also is going to have a fade out of 0.2 seconds, and it will be also a square wave sound, but instead of a constant constant pitch, let's make the pitch varying over time. So first we need the variable which is going to be initialized to the period corresponding to the MIDI note number 60, and then with each passing sample, the period is going to be shortened by 0.002, which means that over time the sound is going to go up. The pitch is going to go up. And let's have it respond to some parameter as well. And and this parameter will be the speed of the ball. So the higher the speed, higher the velocity, the higher the pitch of the sound. So again, I'm just going to concatenate this number with the string, colon, and then the number. And I will get the number as a velocity, as a magnitude of velocity of my rigid body, which is the ball. And now you can hear that as the velocity changes, yeah, we always will hear something slightly different. Okay, now let's make the countdown at the very beginning. So it's going to be a tick. It's going to be called tick, and it will receive a parameter, which is going to be the MIDI number, and then let's make another sound, and that's the music. And we will need the music welcome, music victory, and also music game over. And each of these is going to be based on a series of notes, of note boxes. And the note is going to have two parameters, not just one, two. The first parameter is going to be the number of 16th notes. That's the exclamation mark converts the number behind it into the number of samples it would take to play a 1/4 note. So if I do this, I'm converting the number into the number of samples corresponding to a 16th notes times the parameter. And the second parameter is the pitch of the note. So let's say 4 16th notes, that's a quarter. This is a C4, this would be a 16th note C4, and so on. And now I will write the music, just a simple jingle. So this is a 1/4 and a half of A4 and a 1/4 and a half of D4, and then an 8th note and an 8th pause, and then 2 16th notes and 3 8th notes, and then 1/4 note at the end. Awesome. And now I want to make the volume envelope a bit more intricate of this melody. So I'm going to make some parts softer and louder to emphasize different parts of it. Alright, so this is the music welcome. And now let's do the other ones. Let's do music game over, which is essentially the same thing. It's just with some modifications of the notes. And as you can hear, these two melodies can sound one over another. So I want to limit the number of instances that can play simultaneously by using this keyword maxInst. So no matter how many boxes I would trigger, only the latest one is going to sound. Right, now I will finish the music victory, which is going to be essentially the same thing, with some slight modification of the notes. And now I have all three: welcome, victory, and game over. All right, and the last sound I need to make is when I miss the ball. I'm going to make it sound a little bit softer, and internally it is going to be a sequence of 3 missed note boxes with these pitches. And the missed note is going to receive a single parameter. It's going to last 1/3 of a quarter note, and it's going to be a fade in from 0, which is going to last 0.33 seconds as well. so the same length essentially. And I'm going to use noise 5, which is this engine-ish sound. And now I'm going to instantiate those sounds whenever needed. So this is the intro, this is the start, this is the game over, and this is the victory essentially. I will just edit the names of those boxes to correspond to what I actually want to play. And so that's the welcome. And that's the game over. And now just for the mist sound. Nice. Yeah, we're almost there. One thing which I did not show in this video is the implementation of the countdown, but I guess that's at this point kind of straightforward. So let's try building it, or let's go over how to build the game. It's actually pretty straightforward. The only thing that you might want to look at is in your project settings in audio, make sure that your DSP buffer size is set to best latency. Otherwise you would get the lag between the action and the actual sound generated by Gradrigo. So as you can see, it's pretty simple. And this is how the final game sounds like. As you could see, it was just a few lines of code, and we have a complete arcade game audio synthesis in place. By the way, separate Gradrigo instances can also be attached to individual game objects, which will allow to utilize built-in 3D sound effects, and I'll show how that might work in a separate video. When you use Gradrigo in your game, please let me know. I'll be very happy to see it. Gradrigo is free for non-commercial projects. So thanks much for watching, and don't forget to subscribe to this channel. And you can also support the development by joining my Patreon. So that is it for today. Thank you very much, and until next time.